Good day, learners. Welcome to Jokchem.Edutech, where you get better understanding of chemistry. Today, we shall be learning monoatomic elements and diatomic elements. We shall be learning monoatomic elements and diatomic elements. Why are we learning monoatomic elements and diatomic elements? It's very important to know those two elements, especially when you want to write balanced chemical equations. And that is why it's very necessary you learn it. Now we have examples of monoatomic elements. All these examples are just from your first 30 elements that we have in our first series. Now look at examples. We have potassium, you see, the symbol is K, sodium, calcium, magnesium, aluminium, zinc, iron, copper, beryllium, lithium, and boron. These are from the first 30 elements. So these are the elements that you write as the way the symbol appears. The way their symbols appear. That is how you write them. Look at potassium. It's mono. Mono means one. Mono means one. It means one atom. Element that has one atom. And the way they appear is the way their symbols are. Now look at it. Potassium will be written as K, normal symbol of potassium from column. And sodium, Na from natrium. Na is symbol of sodium. It's one atom. One is the atomic number is always written as a subscript. So K is just 1, sodium is 1. Then look at calcium, Ca, magnesium, Mg, aluminium, Al, zinc, Zn, iron, Fe, copper, Cu, beryllium, Be, lithium, Li, and boron, B. You can see these are monoatomic elements from the first 30 elements. These elements usually appear in chemical reactions often, and that is why I specifically chose them for you for better understanding of balanced chemical equations. Now, diatomic elements. What are the elements that have two atoms? Di means two in chemistry. What are those elements? So, from the same periodic chart in our previous videos, we have some elements there that are diatomic. Now, these elements include, look at it, the atomic elements include hydrogen, chlorine, bromine. Iodine is included because it goes on with all these chlorine, bromine, iodine, oxygen, and nitrogen. So these are diatomic elements. It simply, di means two, as I've told you. Now, if you want to write hydrogen, instead of write ordinary symbol of hydrogen as H, remember, ordinary symbol of hydrogen in our previous example is just H. But hydrogen, if it wants to participate in any chemical reaction to give us any useful product, it has to be written as H2. This two means two atoms, two. See, di, two atoms of hydrogen. It cannot be single H. So if hydrogen wants to participate in reaction, it will always be H2. That is how it's done. Now, fluorine too, it has to be F2, chlorine will be Cl2, bromine will be Br2, iodine I2, oxygen O2, nitrogen N2. So these elements are specifically selected for better understanding of balanced chemical equations. Now, how do we use it? Now, if question asks you, write equation of chemical reactions for some word problems such as this. Look at it, equation of reactions. Write a balanced chemical equation for reaction between hydrogen and oxygen. You see, another one says reaction between sodium and chlorine. How do you go about it? These elements are fetched from the first 20 elements. How do you write it? The first one says write reaction between hydrogen and oxygen. So I've told you, you will look at it. Oh, is hydrogen a diatomic element or monoatomic? You go to oxygen too. Is it monoatomic or diatomic? Then that will give you clue to know what to write and what are they going to form. And in balancing of chemical equation, the elements you start with are the ones that you will get as products at your right hand side. So look at the way I want to write equation between hydrogen and oxygen and how I will balance it for useful products they will form. Look at hydrogen. I cannot write ordinary H. I've told you anywhere hydrogen wants to be appeared in a chemical reaction, it has to be H2. This is now your hydrogen now. See, it's not symbol you will write. Then plus oxygen will appear as O2, right? And they are gases. See? Now we have just two elements, hydrogen and oxygen. So whatever you want to get here must involve only hydrogen and oxygen as the atoms that will be here. And when they combine, as I said, compounds will form. So compounds comprise of a combination of two or more elements that's chemically combined. You see, hydrogen and oxygen want to combine now. The two products we will have here will still be hydrogen and oxygen. Then what is the formation? How will it form? It cannot just be, and it cannot be this. No, this is wrong. So for you to form compound, you use combining powers. What I told you in our earlier video, I said you use combining power to form the compound. Now the compound that we form now, you quickly take the combining power of that symbol of hydrogen, which is 1. Remember, oxygen will carry 2. You see, 2 this. So what it will form now will now be what? H2O. So this is what we have. And this H2O is water. So combination of hydrogen and oxygen will give us water. The question says we should balance it. If you look at this one now, you will now check the number of atoms at both sides. This is left hand side, this is right hand side, and this is your left hand side. Left hand side comprises of hydrogen and oxygen that are reacted, and this one contains water that the two of them formed. But you must make sure that the number of atoms are balanced. How do you do it? So H2, H2, very good. Okay. Then O2, it is only one oxygen here. There's no 2 here because of the combining power that they will usually use to form the compound between the two elements. So we now have 1. So automatically you must use coefficient. We have what we call coefficient. Coefficient is nothing but any number, maybe 2, 3, 4, any whole number that you can just quickly choose and believe that will serve purpose of balancing your chemical equation. Now I put 2 here. As I'm putting 2 here, this 2 is multiplying this subscript of 2 in down hydrogen here, you see. 2 times 2, hydrogen has become what? 4. So automatically I will cater for the needs of hydrogen here. Now we have 2 times 2, I have 4 hydrogen atoms. Here I have 4 hydrogen atoms, and 1 is here already based on what hydrogen has given oxygen here. You remember? H1O2. You see 1 is here already, 2 is here. So this 2 is multiplying the 1 here that I did not put. So we have 2 times 1, we have 2. So we have 4 hydrogen atoms, and we have 2 atoms of oxygen, giving us 2 atoms of hydrogen and 2 atoms of oxygen. So this equation is now balanced. This is balanced. That is how we get balanced chemical equation. You can see that when I put this and this together, I did not put answer as because I have seen that this is H2, because I said diatomic and this is diatomic, and I did not form H2O2. I have to form this compound from using their combining powers. The combining power of hydrogen and oxygen will give us the product the two of them will produce. And this is water, and this is how it's balanced now. So balanced chemical equation of hydrogen and oxygen will be 2H2 plus O2, giving us 2H2O. The second question says we should write a balanced chemical equation for reaction between sodium and chlorine. Again, as reactants, those two elements that are reacting together, you look at them, you see sodium, you write the symbol. now we are doing between sodium and chlorine. You see? So you write the symbol. What's the symbol of sodium? No, of course, the symbol of sodium is Na. Symbol of sodium is Na. So we have Na plus. You see, I've told you it's monoatomic in the example. Na is Na. It's not Na2. So that's how we just put it. Then for the chlorine now, we have Cl. See, is diatomic. It cannot be Cl. That is how it's being written. That is how it can react to form a compound. So we have Cl2. Then the formula, we use combining power between the two of them, as I've said in the earlier example that I gave you on water. So we have Na, you quickly write, check the group. In our previous video, we have 1. Chlorine is 1. You do like this, 1 is here, 1 is here. So the formula will now be Na1, Cl1. You see? For 1, what's 1? No need to put 1 now. So it's NaCl. I did not say because it starts from Na and Cl2. I put my Na, my answer as Na2Cl. This is very wrong. I formed the compound sodium chloride from their combining powers. So now this is what we have: sodium, chlorine, forming sodium chloride. You can see. Now it remains balancing of the number of atoms. So look at it. You will agree with me. This is just 1 sodium. We have 2 atoms of chlorine. We have 1 atom of sodium, another 1 atom of chlorine. So we need to balance it. This is clear, but chlorine 1 here, and this is 2. So automatically my coefficient will be what? To be what? 2 here, to be placed here. See? Have you seen it now? So something has happened to sodium. It's now these 2, don't forget it to multiply the subscript here, which is 1. 2 times 1 is 2. So sodium is now 2. So now I have 2 atoms of sodium. Automatically my coefficient will be here. So that it will multiply 1 here. We have 2 atoms of sodium. We have 2 atoms of chlorine. Let's check. 2 atoms of sodium. 2 times 1 here, 2 atoms of chlorine. So the 2 of them now, we have 2 atoms for each element they reacted together. So this gives us sodium chloride. So this equation is now balanced. You can see. Very simple. This is how to balance equation in chemistry, especially for binary compounds. Binary compounds are just compounds that are made up of just 2 elements. 2 elements, When you talk of di, 2 things. So we have binary compounds, only sodium and chlorine. Another binary compound, only hydrogen and oxygen. This is where we have to draw our curtain today. Thanks for learning with us. Keep on tuning to Jokchem.Edutech, where you get better understanding of chemistry always, anytime, anywhere. Now, don't forget to put on your notification bell, subscribe, like, comment. Thanks for your audience. Thanks for learning.